Today we're going to be working on Notes 3.1, pages 44 through 46 in the book. In Chapter 3 we're discussing motion. If we were to actually define what motion is, we could define motion as a change in position of an object. In order to visually see that, we usually draw it by representing what's called a motion diagram. It shows the position of an object during its motion. Many different types of motion diagrams exist. It's basically like a flip book. If you were to take the individual pages out of a flip book and lay them side by side, that would work as a motion diagram. It's showing an object as it's moving throughout time. A simplified version of a motion diagram is called a particle model. Now, looking at a couple of different particle models here, we can see a couple of things happening. For example, in this first particle diagram, particle model, we have a single dot, and as time moves across to the left or to the right, nothing is happening. The dot hasn't moved, so this would be a case where we have something that's not moving at all. In our second example, we can see as time moves on that the distance between the dots is the same length. In this case, we would have what's called constant motion. For every increment of time, we move the same distance. In the third one, we can see the dots start out really close together, but end up really far apart. In this case, we have an object that's accelerating. As time goes on, it's moving faster and faster and faster. The opposite of that would be what the particle model diagram on number 4 shows. We have dots that start out really far apart, and as time goes on, the dots get closer and closer together. Now, when talking about terms of speeding up and slowing down, those are all just different explanations of operation definition. So saying an object is speeding up, or an object is staying at a constant speed, or an object is standing still, or an object slowing down. Those are all different operation definitions. So in the case here of a person, we can see that even though we don't have a time scale, we know that as we move left to right that time's going on. The increments between each division shows that the man is equal distances over each time interval. So we would say that this is constant motion. That would be our operation definition. In this case, he starts out really far apart, and as time goes on, he moves less and less over each time period, so that would be slowing down. Now, for practice, what I'd like you to do is to take out a piece of paper and draw particle diagrams, 3 different ones. First one being draw an object moving at constant speed. Second, to draw an object starting from rest and speeding up. And third, please draw a particle diagram of an object starting from rest, speeding up, reaching a constant speed, and then again slowing down to reach a stop. Please have these ready by class tomorrow.